Friends, let's learn electric field on the equatorial line of an electric dipole. For understanding this, we require a dipole. Here we need two charges. This is minus q charge and this is plus q charge. These two charges forms a dipole. Let us the center of this charge is this. So draw the line from the center. This line is said to be bisector of dipole and this line is said to be equatorial line and this is said to be broadside on position. So the heading electric field on the equatorial line means electric field on the bisector of dipole or electric field on broadside of dipole. So this line can be upside of the dipole or this can be downside of the dipole. We have to take one position to understand this. Let us take the upper position. Now let us join these 2 points. Then due to this plus charge, electric field will move outside. This will move outside. So this will move away from the charge. So we will extend this line, this line. So this give you E, let this be A point, this is B point, this point is C. So this is E due to charge at B. Electric field due to negative charge will go inside the negative charge. So this is electric field E due to charge at A. Now let us draw a parallelogram using these two vectors. So when you draw the parallelogram, you have parallel lines. This is the diagonal of the parallel lines and this diagonal is said to be E equatorial. This is the equatorial electric field on the equatorial line. Now let this be O. So from A to O is A, from B to O is again A. This is P dipole moment from minus to plus side. Here is 90 degree. This angle is theta, then this angle is also theta. This line and this line are parallel lines. So this angle is equal to this angle, alternate interior angles. And at the same time, this angle will equal to this angle, corresponding angle. So this add up and this become 2 theta. Now from O to C is R. Let O to C is R. Now it is a right triangle in which this line and this line are same and this is R square plus A square under root. So we have drawn the construction. We required to find E equatorial. First of all, we will find E equatorial at C due to plus charge at B and minus charge at A. So electric field at point C, this point, due to minus q charge at A is, this is said to be EA electric field, EA, and EA is equals to K minus Q magnitude upon distance A to C. A to C is R square plus A square under root. So right here this is R square plus A square under root whole square. And direction of EA is C to A. So right here C to A. This square root can be eliminated due to this square. So you have KQ upon R square plus A square and direction is CA cap. Let this be question number 1. Electric field at point C due to plus Q charge at B is. Now you have to find electric field at point C due to plus Q charge at B. So this is EB and the formula is K Q magnitude upon distance from B to C. So the distance from B to C is R square plus A square whole square and direction is from B to C. BC. This is BC cap, which you can write KQ under KQ divided by R square plus A square, and direction is BC cap. This is equation number 2. Equation number 2 and equation number 1, when you observe it, you find that both these two equations magnitudes are same. KQ upon R square plus A square. KQ upon R square plus A square. So magnitude is same. So we can write from equation 1 and 2, A magnitude is equals to B magnitude, which is equals to KQ upon R square plus A square. Let this be E, single word E. Let this is equation number 3. Now we have find the two vectors, that is EA and EB. Here is a parallelogram, so we can apply parallelogram law of vector at this point to find the resultant. So using parallelogram law, so what you have? You have using parallelogram law of vector addition. You have E equatorial magnitude is equals to EA magnitude square, EB magnitude square, 2EA EB cos. This angle is 2 theta. This is 2 theta. Give a bracket sign here. This is E equatorial. I am writing this side or writing this side. Now, from using equation 3, you know that EA and EB are same. So, at the place of EA, EB, EA, EB, we will write E. So, this is E square 2EE cos 2 theta under root. Add this two, we have 2E square, square it, we have 2E square cos 2 theta under root. Take out the common term, which is 2E square under bracket 1 plus cos 2 theta. This is said to be E equatorial. Now you know that 1 plus cos 2 theta is equals to 2 cos square theta. So therefore you can write E equatorial equals to 2E square into 2 cos square theta under root. From here 1 2 is taken out. E square, from E square E is taken out, and from cos square theta cos theta is taken out. So E equatorial equals to 2E cos theta. So you have E equatorial is equals to 2 into the value of E can be written from equation 3, and the value of E is KQ upon R square plus A square, and the value of cos theta, here you have in right triangle CAO, you have cos theta is equals to base by hypotenuse. So base is A, that is AO, and hypotenuse is AC. So AC is R square plus A square under root means power half. So here I am writing the value of cos theta, which is A, it is R square plus A square power half. So you have QA2. Q2A is P, that is dipole moment. So you have, this is KP dipole moment. And this power is R square plus A square. Here R square plus A square power is 1. And here power is half. So power 1 plus half, when you add up, you get 3 by 2. So you have R square plus A square power is 3 by 2. So we get the value of E equatorial. It is not vector here till. We get the magnitude of E equatorial. Now you have the magnitude of E equatorial, which you have written here, the value Kp divided by r square plus a square 3 by 2. If you want to write in vector form, then you have to see on board that P is in x-axis direction and E equatorial in negative x-axis direction, that is P and E equatorial are anti-parallel. So you write vectorically E equatorial equals to minus k P vector upon r square plus a square 3 by 2. This is in vector form. When this C point is very far apart, then when this C point is very far apart, then R is very greater than a 1. So you can neglect, so a square is neglected. So you can neglect a square here. Neglect a square, you get E equatorial is equals to minus Kp upon r square into 3 by 2. Cut this 2 symbol. So what you get? You get E equatorial is equals to minus Kp upon r cube. Here also you are saying that E equatorial is proportional to 1 by r cube. Thus, what you understand? You understand E equatorial is proportional to 1 by r cube. Note this. In the same way, A axial was also proportional to 1 by r cube. Now, to better understand this, let us have a numerical for you. I am giving you a numerical based on this topic. Let us have a dipole minus 3 microcoulomb here and plus 3 microcoulomb here, separated by 2 mm apart. This means that distance is 2 mm. Let this is the midpoint of dipole. At this point we required E equatorial. This is P dipole moment from minus to plus side. This is the direction of E equatorial. Then what will be the value of E equatorial if this r is equals to 3 meter? So the question is very clear. This can be solved by the formula E equatorial equals to Kp upon r cube. Here you have to first find P. So you know that P equals to Q into 2a. So Q is magnitude of either charge, that is 3 10 to the power minus 6, and 2a is this distance, which is 2 millimeter. This means that 2 10 to the power minus 3 in meter. So you have 6 10 to the power minus 9 and the unit is coulomb meter. So this is coulomb meter. So you have P. Now put the value of P here and put the value of R, you will get the value of E equatorial. Therefore E equatorial is equals to Kp upon r cube. The value of K is 9 into 10 to the power 9. The value of P is 6 into 10 to the power minus 9 and R is 3 meter. So it is 3 whole cube. So you have 10 to the power plus 9, 10 to the power minus 9 will cancel out and you have 9 into 6 here, and the denominator side here you have 3 into 3. So this 3 will cancel out, you have 2 here, 3 cancel out, you have 3 cancel out, so you have 2. This means that what you get E equatorial equals to 2 and the unit is Newton per coulomb, or you can say that voltmeter, or you can say that 2 volt meter. This is the value of E equatorial, and if you say about the direction is opposite. So in that case you have to write here A and write here B, and for that case you have to write the answer in direction. If you want to write, then you write E equatorial is equals to 2 Newton per coulomb, and direction is opposite, so from B to A, so you have to write BA cap. This is the answer. Thus, you understand what is the expression and derivation of electric field on the equatorial line, on the bisector, or on the broadside on position of an electric dipole, and how to solve numerical. So do like, share and subscribe my channel. Thank you.